Review lesson 4.1 to 4.3 is this video. Let's begin. Number 1 is a detour proof. Detour proof meaning you prove one set of triangles to prove a second set of triangles. So let's mark our picture. QR is congruent to QT. Angle 1 is congruent to angle 2. We want to prove these two triangles here. Well, you have to use your visual spatial skills to realize that RWT is an isosceles triangle, which means if these two angles are congruent, these two sides are congruent. And now we can prove big triangle QRW and QTW by side, side, in the reflexive piece QW side. So QR is congruent to QT given. From the reflexive, reason 1, QW is congruent to QW. And from angle 1 being congruent to angle 2, reason 2, if angles then sides, RW is congruent to WT. These three give us reason 3, triangle QRW congruent to triangle QTW. From there we need to figure out what we need to take. Well, what I would take would be angle 5 and angle 6, because then that helps me prove QTE and QRTE, and we got side angle and then the reflexive piece of QE this time. So we'll take angle 5 congruent to angle 6. We will rewrite QR congruent to QT. We will use reason 1 again. Let's say QE is congruent to QE. Put it all together. We just proved triangle QRE, triangle QTE. Put up the wall, ran out of room, go down below. Reason 4 again, because it's CPCTC, angle 3 is congruent to angle 4. And our proof is done. Reason 1 was reflexive. Reason 2 was that if angles, then sides. 3, side, side, side. 4, CPCTC. And 5 was side, angle, side. There's a detour proof. You will have one of them on your quiz. Question 2, find the midpoint of NW. Midpoint means the point right in the middle, so you use the midpoint formula. Midpoint formula, we'll write it out, is x1 plus x2 over 2. That gives you the middle for x. And then you got y1 plus y2 over 2, giving you the middle for y. So what do we have here? We have 6 plus negative 1 is 5. 5 divided by 2 is 5/2. And then we have 2 plus 4 is 6. 6 divided by 2 is 3. B, to what order pair would you draw the median from W? Well, it comes from W going to the middle over here, causing these to be congruent. So we need the midpoint between these two. So we have 3 plus negative 1 divided by 2, and negative 5 plus 4 divided by 2, simplifying to 1 and common negative 1/2. What order pair would you draw the median from N intersecting WY? There's that one. Do the same thing again, using these 2 points this time. We got 6 plus 3 divided by 2, and we got 2 plus negative 5 divided by 2, simplifying to 9/2 and negative 3/2. They want to know what is the sum of these two? Well, 9/2 plus negative 3/2 is 6/2, which is 3. Question 3. The center of the circle is at 3, 5. So we're looking at something like this. Center is 3, 5. We got to point at -4, 1. We're going to find the other endpoint. So I would use the midpoint formula. Call this x comma y. So we got x plus -4 over 2 equals the middle of 3. And then the second equation would be y plus 1. Those are the two y's divided by 2 equals 5. How do you solve it? Multiply by 2. Do not change the top. The 2's cancel each other out. Add the 4 over. X is 10. Over here, multiply by 2, canceling them out. Y plus 1 is 10. Minus it over. Y equals 9. So you get the answer 10 comma 9. Cruising. Hopefully you are good because all those are on the quiz. Number 4 is a detour proof. You see the information marked. There is a midpoint causing these two to be congruent. We have right angles here and here. These two pieces are congruent, so then 1 and 2 are left also congruent. So we can figure out that 3 and 4 are congruent because we can subtract, and we can prove SNT and RMT because side angle side. We had M R congruent to NS. We have the angle, which is the right angles. So angle PMT and angle QNT are right. Arrow out, giving you angle PMT congruent to angle QNT because of all right angles congruent. But underneath it, 1 is congruent to 2, giving us reason 2, angle 3 congruent to angle 4 because of subtraction. The last one was T was the midpoint of MN, causing us reason 3, MT congruent to TN. Bracket these all together. Up to reason 4, we prove triangle RMT congruent to triangle SNT. From there, we need to figure out what we need to take by CPCTC. What I would take would be angle 5 here and angle 6, because if these two angles are congruent, you've got angle, side, and the right angles again angle, proving triangle PMT and QNT congruent, which then by CPCTC makes the other two angles you want congruent. So angle 5 congruent to angle 6. Reuse reason 1. Angle PMT congruent to angle QNT. And rewrite from the midpoint, which is reason 3, MT congruent to TN. These three together. Oh, ran out of room. Put up the wall. Up to reason 6. Triangle PMT congruent to triangle QNT. Which then by CPCTC again, which looks like it's reason 5. Angle P congruent to angle Q. We need our reasons. Reason 1, all right angles congruent. 2, we did subtraction. 3, you see the word midpoint, so it's def of midpoint. 4, side angle side. 5, CPCTC. 6, we're at angle side angle, and we're done. Question 5 is supply the diagram set up in proof. So we draw ourselves a picture. We have a nice isosceles triangle. We'll call it A, B, C. It has an altitude inside D, so we know it's perpendicular. We're trying to get that it has an angle bisected, so we're trying to get the two angles up here being bisected. So our given is that AD is perpendicular to BC, and that AB is congruent to AC, so I'll mark that in the picture. We're trying to prove angle 1 congruent to angle 2 to be the bisector. Well, we got the right angles, and we got the side across from the right angles. That's the hypotenuse, so we know it's hypotenuse leg. So we have HL triangle. The hypotenuse is AB, is congruent to AC. The leg is from the reflexive, reason 1, AD, congruent to AD. And then from the triangles, we get the perpendicular, AD, perpendicular to BC. Reason 2 gives us angle BDA and angle CDA right, which then gives us triangles BD, BDA, and triangles CDA right. Triangles all that together gives us triangle BDA congruent to triangle CDA. That's reason 4. Ran out of room, but we finished up. Reason 5, angle 1 is congruent to angle 2 because of CPCTC. Let's give our reasons for that. Reason 1 is reflexive. Reason 2 is def of perpendicular. 3, def of right triangle. 4, HL. And 5 is CPCTC. Hopefully you're doing well so far. Number 6. BD bisects AC, so this line bisects, causing these two to be congruent. AB is congruent to BC. We want these perpendicular down here, so I'm going to give these two numbers. We know that this side is reflexive, so we can prove the two triangles by side, side, side. We were given AB is congruent to BC. We know that BD bisects AC, which gives us AB congruent to BC. And then from the diagram, reason 2, BD is congruent to BD. So we prove triangle ABD congruent to triangle CBD. And once those two triangles are congruent, we can say angle 1 is congruent to angle 2. And we can finish it up by saying BD is perpendicular to AC. Reason 1 is def of segment bisector. 2, reflexive. 3, side, side, side. 4, CPCTC. And 5, if two angles sup and congruent, then perpendicular. And last but not least, our system. We know these two make a straight line, so we can set 7x minus 4y plus 3x plus 2y equal to 180. And we could set these two, which is 3x plus 2y plus 2x plus 60 equal to 180. So the top equation becomes 10x minus 2y equaling 180, and the bottom one becomes 5x plus 2y equals 120. This works out nicely because the y's already cancel out. 15x is now equal to 300. Divided by 15, x is 20. What do? We plug it back in somewhere. So we'll plug it back into 5 times 20 plus 2y equals 120. This is 100 plus 2y equals 120. So 2y equals 20, making y equal to 10. We want to know if it's perpendicular. Well, you plug it back in somewhere. So 3 times 20 plus 2 times 10 needs to equal 90. This is 60. This is 20. We add them together, we get 80. So it is not perpendicular. Good luck to you on the upcoming quiz. Hopefully you studied well or you've watched this video.